Our last video for 3-4 is a real-world situation where linear programming might come in handy or might be used. So for this example, as a receptionist for a veterinarian, one of Dolores Alvarez's tasks is to schedule appointments. She allots 20 minutes for a routine office visit and 40 minutes for a surgery. The veterinarian cannot do more than 6 surgeries per day. The office has 7 hours available for appointments, so they only work 7 hours a day. If an office visit costs $55 and the surgeries cost $125, find a combination of office visits and surgeries that will maximize the income of the veterinarian practice or that the veterinarian practice receives per day. So the vet decides, hey, I want to make as much money as I can in one day. I can do at most 6 surgeries. Each piece, if I'm just doing a routine visit, that's going to take 20 minutes. If I'm doing a surgery, it's going to take 40 minutes. And I want to find out how I can make sure that I'm making as much money possible as I can each day. So one piece of information that's going to be helpful here, let's change right away. 7 hours, because they're open for 7 hours. 7 hours is actually the same as 420 minutes. Just multiply it by 60, because 60 minutes in an hour would come out to 420 minutes. Okay, so our first step in a problem like this is we need to define the variables. Well, they kind of already did that for us. V is the number of office visits. So if V was 1, they had 1 person come into the office that day for just a quick checkup. So they made $55 off of that because the office visits are $55. We also know that that spent 20 minutes of the vet's time because each visit was 20 minutes. S is going to be the number of surgeries then. So again, for every S that we have, we're going to get $125 because each of those is a surgery. And again, each S is going to take 40 minutes as well. That's another thing to kind of keep in mind. But those are just kind of the variables that we have, V and S. Step 2 asks us then to write the system of inequalities. So that might sound kind of weird at first, but really you're just taking the information given in the example and writing it into kind of a mathematical format. If we move it aside, we'd say S and V both have to be greater than 0. S is greater than or equal to 0. V is greater than or equal to 0. Why do we have to say that? Well, you can't have a negative number of surgeries in a day. You can have 0, so S can equal 0. You can have more than 0, but you can't have a negative amount of surgeries. Same thing with V. You can't have a negative amount of visits. They can come once. You can have 2 visits. You can have 7 visits, whatever it is. But you can't really say there's a negative number of visits. So we're just going to kind of constrain everything into only positive numbers. Another thing we know is S has to be less than 6. The vet can only do up to 6 surgeries per day. He can't do any more. He can do exactly 6. They can do 1, 2, 3, 4, 5, or 6. I guess they can do 0 too, but they can't go anywhere above 6. So it has to be less than or equal to 6. The last one might have been the more difficult one to find out. We'd say 20V plus 40S is less than or equal to 420. Now, where did that come from? Well, the 20V part is for every visit, every regular office visit, that's going to take 20 minutes out of their day. So 20 being the minutes times however many visits there are, that's how much time they spent just doing the visits. So this part was the time for visits. The 40S, that's the time they spent on surgeries then. Each surgery takes 40 minutes, so 40 times however many surgeries they do, that's just the total time that they spend on surgeries. This 420 then, that's the total amount of minutes per day. Okay, you can't go over that many minutes. The vet doesn't want to spend more than 420 minutes at work. Okay, they've only got 7 hours available. So all of your visits and all of your surgeries, they all take time. You add up all that time and it has to be less than or equal to 420 minutes. So that's our system of inequalities. We actually have 4 of them to work with. So the next step then is we need to graph those inequalities. Before we go on to graphing them, let's change this inequality into something making it a little more easy to graph. Now on our graph here on the side, they used office visits, or our V, as our vertical axis here, kind of our y-axis. We can think of this as y and think of this as x. So if our visits are y, we want to get that one alone. So for visits, y is v, I should say. We're trying to get v alone. So if we're trying to get v alone, we're going to subtract 40s from both sides, which is going to leave us with 20v is less than or equal to negative 40s plus 420. Our next step then is we're going to divide everything by 20. So we have v is less than or equal to negative 2s plus 21. So now that we know all that, we can start graphing things. We'll start with this one that we were just looking at. We'll plot our point right at 21. And again, that's to say, if we didn't do any surgeries, then we'd spend all our time in the day just doing office visits, and 21 would be our maximum. That would be at that point there. Now, moving along the line from there, if our slope is negative 2, I have to go down 2 over 1, down 2 over 1, down 2 over 1, and so on. Plotting out this line. It actually doesn't even hit right at an actual spot. We kind of get caught right in the middle there. We'd actually run out of time to do everything, or at least full pieces. But that's what our line is going to look like just from that inequality. Now let's look at all the other inequalities. And again, that one is going to be a solid line because we have the or equal to. And it's going to be everything less than that because we have the less than or equal to. So I might as well connect that line right now. And we'll know that it's everything going in this direction. I'm not going to shade all of it right now, just to kind of save us on some stuff. So it's everything below that line. Now our s needs to be greater than 0. That just means here's our line, and we just need everything above it. It needs everything that's positive. Similarly, for v is greater than 0, we'd have this line here, and we need everything above it, everything to the right of it. Okay, so we're basically just kind of working everywhere inside this triangle. Now the last piece that we have is this s is less than or equal to 6. We can only do at most 6 surgeries. So that would make this line right here. And we need to go less than that, so everything within there. So the only number or the only combinations possible of surgeries and office visits would be anything in this area. Okay, so we could come right here and say it would be possible for this vet to do 4 surgeries and 8 visits in a day. He would definitely have enough time to do that. Okay, so given all of our constraints, everything in this area is the number of surgeries and visits that the vet can do in a day. So now that we've graphed everything, we need to find the coordinates of our feasible region. So the coordinates, again, are just the corners. So we'd have one here, one here, one here, and one here. So as we look at those and try to name them off, that top left one is at 0, 21. The bottom left one is at 0, 0, kind of right at the origin. Again, it is possible that the doctor doesn't want to do anything that day, so he does no visits and no surgeries. This top right one, this corner piece right here, that's at 6, 9, and then the bottom right one is at 6, 0. So those are our coordinates, or our vertices for our feasible region. Moving down, giving us some space to work here, we need to write a function that's going to be maximized. Now, if we go back up to our information, looks like over here it says that an office visit costs $55 and most surgeries cost $125. Okay, and that's where all the income is coming from. The visits and the surgeries each being well, one being $55 and one being $125. So the function that we are going to create from this is our function of surgeries and visits equals 125 times S plus 55 times V. So this right here is the amount of money that we're going to make based on how many surgeries and visits we have. So what do we do with that number of surgeries? We multiply it by 125. That's the money we're getting just from surgeries. What do we do with the number of visits? We multiply it by 55. What do we do with those numbers? We add them together, and that's how much money we make based on that one day. So if one day we had this many surgeries and this many visits, we plug it into this function here, and the output then, what it gives us, is how much money we made that day. So now that we have our function set up, we substitute in the coordinates of the vertices, so we plug these values in to our function, and whatever it spits out, that's how much money we would make at the end of that day. So looking at our things to plug in, again, we're going to need to plug in, need to plug in 0, 0, 6, 0, 0, 21, and 6, 9. When I plug in 0, 0, it's going to look something like this. 125 times 0 plus 55 times 0. Now, of course, those are both going to end up being 0, so when we add them together, they'd be making $0 that day. On the next one, if I do 6 surgeries and 0 office visits, I would plug that into my function, and it would say 125 times 6 plus 55 times 0. When I calculate that out, I would have $750 from that day. It looks like that came all from surgeries. I didn't visit with anybody. There was no checkups. It was just the surgeries. And so we got $750 just from doing those 6 surgeries. The other possible combination, or the other corner that we could do, 0 surgeries and 21 office visits. In that case, we'd have 0 times 125 plus 55 times 21. When we solve that out, that's going to give us $1,155, $1,155. So again, in that case, we didn't do any surgeries. We just did office visits, and we were able to make over $1,000 that day. Our last possible combination would be if we did 6 surgeries and 9 office visits. Okay, when we do something like that, that's going to be 125 times 6 plus 55 times 9. Now 125 times 6 was this 750. 55 times 9 was 495. So if we add all that up, it's going to be $1,245. So looking at our table then, we need to decide which one of those is the biggest and which one is the smallest. Well, obviously, right here, this 0 is the smallest. That's our minimum value. So we can minimize our function at 0, 0. Okay? And the minimum value of the function is this 0. We can maximize our function by finding our biggest one, this 1,245. Where does that happen? Well, it happens at the point 6, 9. So we had to do 6 surgeries and 9 office visits to maximize the amount of money that we would make that day. So another way to say this, again, the question was, what's the combination of surgeries and visits? Well, if they did 6 surgeries and 9 office visits, they would get the most money. And again, how much was it? It was $1,245.